Hey fun fans, it's Evan here. I'm with team 9496 Lynk. This is a team that has had an incredible rookie year and they're looking to have an incredible second year as well. We'll be looking at their robot, their end effector, their unique programming LEDs, and their really unique deep climb. I think they'll have a fantastic season this year, coming right after their fantastic season last year. All right, so Nathan, if you can tell me a little bit about your end effector, your climber, and what all went into building this.
Yeah, so basically, starting out for the end effector, we actually went through a couple iterations. It's actually V3 of the end effector. What we saw was basically a fixed angle end effector. We like fixed angles. So basically, the coral just passes through here at a fixed angle, and it stays there, and it's held there until it's shot out. And that's pretty much it. Very simple end effector. We have a gearbox right here that controls it. This belt controls the top part, and this belt goes down into this shaft that goes back into this gearbox that controls the rest of it, and these belts across it alternate the front wheels.
All right, and you can tell me a little bit about your elevator as well. Is this a custom elevator?
Yes, it is a custom elevator from Elliot from 111 Wildstein, and he did help us with the process of actually making the elevator. He gave us guidance, and it was his design, and it was actually very useful for him to actually help us in that. And with the elevator, it's actually pretty fast. We actually geared it up a little bit to make it go faster. We added more power to the motors by 100%, I think it was. And it does go up to L4 pretty fast if Jimmy likes that. It's in person, it's very, very loud. I don't know how loud it's going to be on camera, but it is very loud going up and down. And honestly, it's pretty accurate. And again, Elliot, thank you for helping us out with the elevator.
Awesome. And so what made you guys go with the funnel and intaking from the human player station over having a ground intake?
Mostly because we didn't want to reach stuff over the bumper and the complexity it would have, and just knowing the simplicity of just having it coming straight from the source would be beneficiary for autos, and no need for rotation and just easier function.
Awesome. Yeah, you guys have really emphasized the simple but very effective through your 2 years. You got Samuel, if you can go ahead and talk a little bit more about the deep climb you have.
Yeah, I'd love to. So right here is our deep climb. It's inspired from 8044, and it's basically this arm, these cables, and then a Kraken down there going into a gearbox run by this chain right here. So you want to drop it right there. It drops down. Our funnel comes down right there, so that it gets out of the way of the chain right here when it comes up. This would come up, unhold the chain. We can do it real quick. Comes there. Now hold it. Chain will be right here, and the sides of the actual cage go on this cat tongue right here. It works great, and it's avoiding everything. And this right here, when it's down, is a guide for where the actual cage goes in. And you line it up like that, and we're ready to go.
Awesome. This is a really cool design. I haven't seen many like it. So what made you guys go with this design? Did you take inspiration from anyone?
Yeah, 8044, and I mean, it looks great from what we've seen with them, and it fit our design perfectly. We knew we'd be able to fit it in. So far, it's worked great at this event, and hope it will for it.
So it's one thing to make it robust, it's another thing to make it fast. So through software, we've automated most scoring processes on this robot. So this robot's controlled by 2 joysticks, these 4 buttons, and 2 triggers. So these buttons set what level the elevator's in. So L1, L2, L3, L4, and then right branch or left branch. And then the robot does it all. It aligns, it scores, it backs up. And the only thing the driver has to do is make it to the source. Same thing for algae. So it knows that when it has an out piece, or if it doesn't, so it'll automatically go for algae and line up for that.
All right. That's really cool. For auto, do you have a sensor to tell when you've gotten a coral from the human player station?
So we so at Gainesville we had proximity sensors, the cheap Amazon ones that you get, but we had a lot of issues with those, with it getting false readings and everything, and just ruining our state machine. So we switched to CTRE CAN ranges, which is a time of flight distance sensor, but we're just basically using them as proximity sensors. So they detect when a coral's like right here, so you don't get any bad readings from this like poly ever flying or anything. And they've been like really robust so far through this comp.
Awesome. So you use these to detect when the coral's gone auto and wait until that's happened to score, right?
Yeah. So when this first sensor's triggered, the state machine says we have a coral, and then it starts flying to the reef, and then once it hits this sensor, it's ready to score it, and then once it drops, it goes to the next auto path, gets another piece. Hopefully by DCMP we'll have it to 4 pieces, but right now it's at 3.5.
Awesome. This is a super impressive robot you came up with. Thank you for sharing it for everyone, and I wish you guys the best of luck during your competition.